Okay, today we're going to be looking at distances between points and when lines are perpendicular and what effect that has on the gradients. Distances between points is quite straightforward. It's just going to be Pythagoras' theorem. How would I do questions like find the distance between P and Q? P is -35, Q is 217. I'd do a quick sketch. 3 back, 5 up. 2 along, 17 up. There. I'm going from -3 to 2, so I've got 5 along, and from 5 to 17, 12 up. So I'm doing Pythagoras on 5 squared, 12 squared, Pythagoras, Pythagorean triple, so 13. Nice and straightforward. For B, to go from -2 0 to -8 2, sketch it again, -2 0, -8 2, and there like that. So -2 to -8 is 6 back and 2 there. So I'll do Pythagoras on 6 squared, 2 squared, root 40, bit of surge work, root 4 times root 10, 2 root 10. Simplifying. C, really straightforward. S is the point 23.7 and T is the point -4.7. So in this case, it's just a, because the Y is 7 all the time, it's going to go through the Y7, it's a horizontal line. So all I need to do is find the distance from 23 to 4, so it's just 27. From -4 to 23, 27. Example 2. A, B and C, we need to show that it's isosceles. Quick sketch to allow us to have a rough idea of which two are going to be equal in length. A is the point 4, 6, whatever, up to 10, 4, 6, 4, 6, there's 8, 4 long and 6 up. B is the point 5, -1, and C is the point 10, 4. Not much of an idea from that sketch there. I've got 6, -1, and 4, and I've got 4, 5 and 10. So let's have a look at these things here. See, basically looking at that. So AB will equal from 6 to -1, 7 and 1. Root 7 squared plus 1 squared, root 50, or root 25 times root 2, 5 root 2. B to C is going to be from, I should have put my numbers on, amateur, 5 along and 5 up. And guess what? There we go. Root 5 squared plus 5 squared is root 50. So yes, it's isosceles. I could have shown and done A to C as well, which is from 4 to 10, so it's 6 along and 2, and that would have been root 40. So we've got the equal lines AB and BC. There's your isosceles triangle. Now let's have a look at when it's perpendicular. If I've got a slope like this, I've got the change in y as my height, change in x, there's my base. If I consider what happens when I'm looking at a line that's perpendicular to this one, well, that's equivalent to rotating the thing by 90 degrees. That line there is perpendicular to that one there. So 90-degree rotation. What happens in this case? These two things here are reversed from what they were. This is now the height, which was the base of the triangle, and this is the other way around. So what happens for our gradient? That one, in this case, is going up. The perpendicular one is going down. So they'll have different signs. And one is called the negative reciprocal of the other one. So for example, if m1 equals -7, nice steep gradient, the shallow one, that will be perpendicular, will be positive 1/7, because it's just these two values the other way around, like that. So it's 7/1 inverted to get 1/7. If m1 is 3/4, the perpendicular line is -4/3, because in that case one's positive, one's negative, and in this case we've got change in y 3, change in x 4, and what was change in y and change in x is the other way around. That's it. If you've got a decimal for your gradient, I'd be writing it as minus 9 over 2, so I can then say the perpendicular is 2 over 9. Example 2. There's a point. We want the line perpendicular to that, to this line, y equals 2x minus 3, that goes through that point. So it's nice to state m equals minus a half, negative reciprocal, and then I know y equals minus a half x plus c. Sticking the point 6 minus 1 equals minus a half of 6, which is minus 3, plus c equals 3 minus 1, 2. So y equals minus x over 2 plus 2 is the line that goes to that point and is perpendicular to that. Example 3, 2 points A and B. We want the perpendicular bisector between the two. So let's do a little sketch first. A is the point minus 2, 7, there it is, there's A. And B is the point 4, 10, up there, there's B. And we want the point that's going to go like that. So what I need the midpoint of the two, and then I need to consider the gradient of the things as well. So in that case there, I'm going from minus 2 to 4, which is 6 along, and from 7 to 10, which is 3 up. So my original gradient, m1, is 3 over 6 half, so m2 is minus 2. That's the gradient of this line here. But I also need the coordinates of the midpoint, which is what we did last week. It's the average of minus 2 and 4, 1, and the average of 10 and 7, 17 over 2. Add them together and halve it. So I know it's going to be y equals minus 2x plus c. Stick in 17 over 2 equals minus 2 plus c. C is 17 over 2 plus 2, 21 over 2. So y equals minus 2x plus 21 over 2, or equivalent to that. So that's an equation of the perpendicular bisector. Last example. Triangle PQR, is it right angled? So let's have a decent sketch here. So I've got 7, 2, there's P. 13 along and 5 up. Gosh, almost a straight line, isn't it? There's 13 and there's 5, and the point 8 and minus 3. So if it's a right angle, it's here. So we've got P, Q, and R. So let's have a look at these two ones here. PR and 1 equals, change, I'm going from 2 to minus 3, so it's minus 5 down, and from 7 to 8 over 1 minus 5. The gradient of PQ, and 2 is, in this case here, the change in y is positive. It goes from 2 to 5, so it's 3 up, and then from 7 to 13, 6 along. So that is a half, and if you need to, I can do PR, should have that, M3, let's call it. In this case here, I wouldn't have thought that's going to be perpendicular to anything, but we'll have a check. Changing y goes from minus 3 to 5, so it's 8 up. And then in this case, we've gone from, the y value's gone from 8 to 13, 5, 1.6. And none of those, neither of these are perpendicular to that one. I'll be expecting a gradient of a fifth for that one rather than a half, which is not what I got. So this is not right angled at all. And that's it. So it's perpendiculars means that the product of the gradient is minus 1. If you want distance between 2 points, it's basic Pythagoras theorem. That's all there is to it.